All right. Ladies and gentlemen, thank you for tuning in to our SUI Network's A Complete Guide to zkLogin. I want to start off by asking where you guys are tuning in. So, it would be pretty cool if you can asking leave in the comments where you're tuning in from. And while we wait for some other people to join, I'm just going to show you a quick trailer, a sizzle trailer that we made for zkLogin. Let's see. Okay. All right. I think that wasn't really showing well, so I'm gonna just share the link in the chat on the side. But without further ado, it's my great honor to invite our Miston Labs engineer on the cryptography team, joining from New York. So please welcome Joy.
Hello,
Hello,
everyone.
Joy. I prepared a soundtrack for you, like a welcome soundtrack. I don't know if you can hear it, but I thought it was a pretty cool soundtrack. All right, cool. Thanks, Joy, for tuning in. I know it's early for you, so I'll just leave you to do a quick self-intro before you dive into your workshop today.
Cool. Hi, everyone. My name is Joy. I am an engineer on the cryptography team at Miston Labs. I work on a lot of the cryptographic primitives used on SUI, like signatures and key management and stuff like that. Most recently, been working on zkLogin, which is a new primitive that for people to interact and authenticate with SUI. And I'm pretty excited to be here to share. Cool. Let's get started then. So my presentation today is on everything you need to know about zkLogin, and it ranges from how it works, what problem we're trying to solve, and how exactly you can integrate as an application developer of zkLogin into your application. And also, I want to cover a little bit on the security and privacy questions or considerations that you as developers should be thinking about, and also make certain trade-offs or think harder on. And eventually, I will show a small demo application and also cover some FAQs. And feel free to chat in the comments for any questions. So let's get started. So I think most of you are here familiar with what a wallet is and what a private key and mnemonics and all these scary words out there. And I think um, you guys are probably more familiar with cryptocurrency and how important these phrases are. But for majority of the users, remembering some high entropy mnemonics are very intimidating, and even explaining why there are a lot of words that you need to memorize and not to, screenshot or share publicly is something very different. And especially for non-English speakers, a lot of these words here could be even unrecognizable to remember. So what zkLogin is trying to do is to reuse the existing method for people to onboard to SUI. And the ideas that we wanted to use is that we already have a familiar OAuth login flow that people use on a day-to-day basis to log into a lot of their applications. And we wanted to leverage that such that the user have no need to manage their own private keys. At the same time, you wanted to also achieve this idea of self-custodial, meaning that every transaction still requires your approval, that there's no one actually holding your private key. So that's kind of the idea of how we design zkLogin as a primitive, and we think that it is a very powerful way of onboarding new users to the Sui ecosystem. So first of all, I want to cover really quickly on how OpenID, which is a protocol that standard that people use to log in. For example, Google login to Google, signing with Google is an example of how Google uses OpenID as a protocol. It is a subset of OAuth 2.0. It is something where you enter your password and log into your Gmail account. Google will actually return you this JWT token, or on the right hand side, you can see example of it. So this is an encoded JWT token on the right. On the left, you can see the base 64 encoding, and on the right side, you can see what is actually in there. So what happens when you log in is that Google returns you this payload of a lot of fields here. I'll kind of explain what these means later, and some fields are more important than the others for us. In particular, there is a nonce where as application you can pass in and ask Google to sign over. And it also contains a sub field, which is a subject ID that uniquely identify who you are. And at the bottom is the blue section is RSA signature over this payload. So pretty much you logged in and Google returns to the application saying, this is what the user is logging into, and we verify its identity by providing a signature. So this idea is that because there's a nonce field where the application can define, we can actually see this field called nonce, and essentially you can ask Google to commit to a public key. And we leverage this idea called open public key. What that means is that we embed a public key into this nonce and ask Google to sign over it. So at this point, we actually have a digital certificate over a public key. And imagine that we can also embed some sort of expiration on it so that there is a public key corresponding to a secret key that you own. And then you register with Google saying, please sign over this data. So this is how we register a key with Google in this flow. And there's few questions we want to answer here. Is that now we have ephemeral public key, a key that we don't want you to remember. We don't want you to, remember the private key where you have to write down mnemonics. And by leveraging the zkLogin flow, we wanted this key to be ephemeral, that you never need to remember it. There's few questions kind of comes up. The first one is, how do you persistently identify a user on chain? Traditionally, we derive an address based on a public key. And in this case, because the public key is not persistent, how do we define the address? So we came up with a new scheme here. We define it as a hash over 3 different fields in the JWT token. Specifically, the subfield is a unique identifier that you can be identified within Google, that this is your ID. Think of it as a Google ID. And what is ISS here? It is a field that identifies the issuer of the credential. So in this case, this example, it is google.com. And the third field that we use is called audience, odd. This actually defines what your application is. So for example, you can say this is Sui Wallet, This could be a video game or anything that you register with Google developer account. This is a client ID. So instead of deriving the address out of public key, we actually identified using the persistent field in the JWT token. Second question we wanted to answer is that how do we sign a transaction? As we mentioned earlier in the previous slide, we leveraged this field called nouns where we can set the public key in there. So as a wallet or front-end application, you generate ephemeral key pair SK and PK here, and then you register the PK in the nouns when you log into Google. And then the SK, you keep it in your application where you can sign transactions. And again, this private key, it's not like something you have to always keep secure. It can be used up to a certain period of time. So I haven't mentioned the zk part of zkLogin yet. So far, we are able to use Google as a credential issuer that may have you commit to a public key, and then you use this private key to sign a transaction. But there's one problem here, is that the JWT token is actually quite sensitive. For example, it can see my email address, my full name, and sometimes some providers even include, a profile picture or some information about you. So it is not an option for anyone to submit a JWT token on chain because the blockchain is public. So what is the trick here? We like to leverage zero-knowledge proof to check certain fields of the JWT token is consistent. So what actually goes on chain is that there's a zero-knowledge proof that proves you that you are the owner of this JWT token. And the second part is we still need a signature, but the signature is signed using the ephemeral private key that commits to your transaction. So in this way, we kind of achieve the zero-knowledge part where you're able to prove that you're the owner of the account. You also prove that you have committed to a public key in your nouns. And the third part is that this public key you committed, you did use the corresponding private key to sign transactions. So these are kind of the combination of things you submit on chain to perform a zkLogin transaction. So that's like a very quick overview of what actually happens in the zkLogin flow. It's very important to kind of remember the steps when we're actually looking at the integration details. So after talking about the big ideas, now we look at a little bit closely on what the zkLogin flow look like. Roughly corresponded to what I mentioned earlier, where the user first log in to your application. Say this could be some game, and then the user will see a sign in with Google button, and the user can enter their email, their password as usual, and by setting this ephemeral public key into the nouns, the user essentially finished a flow of committing to a public key. And once we have the JWT token at the bottom here, the authentication token, this is the field that has the RSA signature from Google and the payload that contains the nouns and your user ID. And this part actually goes into a proving service that generates a zero-knowledge proof of who you of this to prove that you are the JWT token is well-formed. And on the other hand, the ephemeral key signs the transaction and can submit it to the blockchain. So now let's dive a little bit deeper on how to integrate with zkLogin. with that flow in the mind. So the overview of all the steps that happens sequentially. First, there is a certain way of configuring the login URL. For example, let's take Google as example again, where you need to configure announce where that is set to a public key, and you also set it to some expirations. Let's say the next epoch on the Sui blockchain on mainnet. So you set it to say the next epoch. And you also need to configure the client ID and the redirect URL. What this means is like, as an application, you wanted to tell Google where do I send the JWT token to, and the redirect URL is what your application is. And secondly, I want to talk about this concept called salt, where it is a value that used to derive your user address. And the third step is that we will now call the proving service to generate a proof by giving it a JWT token. And the fourth step, you wanted to actually sign the transaction with the ephemeral key. And the fifth step, now you have the complete zkLogin signature that consists of the proof and ephemeral signature. So now let's start looking at the actual code. How do you configure the login URL? There are a few fields that you need to specify when you're giving the user a login URL. So there's a couple fields, as I mentioned earlier, client ID and redirect URL, and this nonce. Now let's talk about how do you configure these values. The nonce is the part we mentioned earlier about that commits to a public key. So in your application, you first define what a max epoch is. Let's say on the second section of the code here, you define a max epoch as the current epoch plus 2. So what this means is that this ephemeral key can be active, or the proof is valid for current epoch plus 2 from now. And then now you generate the ephemeral key pair, and that is being passed to generate the nonce. We also define a randomness just to add some sort of value into this nonce so that it's not directly corresponded to your public key. So now we have the nonce. We also now need to configure the client ID and the redirect. It is something quite easy to do. Now let's take Google as an example as well. All you need to do is to define your application in the Google Developer Console. And on the right-hand side, on the top right corner, you can find your client ID that corresponds to your application. On the left bottom side, you can define the redirect URL of your application. It could be, your videogame.com, whatever. So this is the redirect URL that you will find the JWT token being sent to. So now you have configured this login flow for the user. You're able to pretty much build a sign-in with the Google flow for zkLogin. Second, next step, you might ask, how do we derive the user address? As I mentioned earlier, the user address is no longer defined with by taking a hash of your public key. Instead, here we actually derive the address based on certain persistent field in your JWT token in the payload. And now we want to introduce this small detail here. We call it a user salt. This is a value that we introduced This is a value introduced to decouple your Web2 identity with your on-chain address. Why is this the case? We don't want people to be able to derive your sweet on-chain address directly from um, your Google subject ID, which is globally unique for you. So a best mental model to think of this is that it is a two-factor authentication. So for anyone to log in with your to transact based on your zkLogin address, I not only have to be the person controls the OAuth login flow and enter your Google credentials. It is also required for me to know that there's a salt that's associated with my account such that I can derive my user address. And in particular, the salt is not managed by the OAuth provider themselves. So in some way, you're always in control of your account by knowing both the OAuth credential and the salt. There are two options here of where to keep the salt. We'll cover a little bit more of the differences a little bit later. But the idea here is that the salt is not a private key. It is something sensitive because you do need to know it to be able to transact in your zkLogin address. But it's not the only thing it's needed. So there's a decision to ask, say, the user to save this address for you, or you can save it in some sort of backend server for your application. So the user, every time they log in, they will ask you whether what the salt is. So here's an example of how to derive the zkLogin address using the zkLogin SDK. We made an interface called GWT to address that does all the parsing for you of the GWT token. So you can directly derive the zkLogin address as follows. As I mentioned earlier, it is a hash of these three different fields in the payload and a user salt. So now you have your zkLogin address, and you also have the user finish the sign in with Google Flow. How do you actually get the zk proof where proves that the GWT token is well formed? So this is where we there's a backend zkLogin proving service, and you can make a request from your application to get the proof itself. We'll also talk about this more later. There's option to call a prover that is being run by your application backend, or it can also be run the one that we host as an API endpoint. The idea here is that generating a zk proof can be a little bit resource intensive, and we made a decision that this has to be outsourced to a server where the computation is done. So now you get the zk proof. To give you an idea, it is pretty much a long JSON string that looks like a bunch of big integers, and you have this proof on your application. And the next step is to actually sign the transaction. You still need some sort of signing with a private key. The only difference here is that the private key is not something you need the user to memorize or remember, but you still do need to commit to a transaction using a private key. And here we have the ephemeral key pair generated and the transaction block configured to whatever you desire. And the important part is that the transaction sender should be the zkLogin address that are generated a few steps before. Just like how you sign a regular transaction, you use this transaction block.sign with an ephemeral key, and it does generate this user signature field. And this is the ephemeral signature that we mentioned earlier. So now you're very close to being able to submit the transaction. Here we have the proof, and we also have the ephemeral signature. And now we're at a good place to actually assemble both together into one zkLogin signature. It consists of two parts. Generally speaking, consists of two parts: the proof point and also the ephemeral signature. There's also this address seed field that is very useful for the proof verification on chain. It is generated with a couple field from the JWT token as well. And now you have successfully submitted a transaction on chain where you have the proof and the ephemeral signature. So now we have covered the whole flow of how to implement zkLogin. I want to talk about like some of the considerations that you may have while using zkLogin. Some of the security model that I like to have people to think with is that you should always think of zkLogin as a 2FA model. If somebody compromise your Google account, he can steal your money from your zkLogin address. He also need to manage to get the salt from someone to be able to derive your address. So a 2FA or 2 out of 2 multisig, what have you, there's always two parts that are needed to transact out of your zkLogin address. And another thing here is about the JWT token itself. Maybe some of you may have some questions. Oh, what if there's a website that tricked me to log in with signing with Google? They get my JWT, they can somehow steal my money out of zkLogin address. The scope of a JWT token is very important. As we mentioned earlier, there is a client ID that you have to define for your application in your Google developer account or Twitch or Facebook. And a JWT token is only valid for this client ID. In other words, the Google RSA signature actually signs over this value. So if you submit a JWT token that is unrelated to this application, you're actually convinced that you're logging into, there's no way that this JWT could be reused anywhere else. And another thing to highlight is the storage of this ephemeral private key. As we mentioned earlier, ephemeral key is registered with the Google using the nouns field. So it doesn't require a persistent storage of this key. It could be in your local storage in your front-end application. It could also be, in your Chrome extension wallet. And the important thing to note here is that this ephemeral key can always be refreshed. Whenever you refresh it, it changes the nouns field, and it also changes the zk proof. So you can theoretically cache the zk proof for a particular ephemeral private key somewhere in your application, and it only needs to be changed whenever this ephemeral key expires. Let's say every 2 epochs on mainnet in Sui is around 48 hours. After that period of time, your wallet can clear the cache and then force a refresh. And compromising a ephemeral private key is not as much as the end of the world as you losing your private key in a traditional wallet. Exactly because of this, you always need to have the private key, and also on top of that, you also need to authenticate with Google and perform the signing with Google Flow to actually register a private key to be usable on-chain. And other than securities, or we talked about how these fields, how sensitive they are, and how, what it means to steal your funds from your zkLogin wallet. We also want to talk about the privacy considerations. So on a high level, we think about the privacy in the sense that you do have a credential with Google. You do have, your unique Google ID, which is the subfield that is used to derive your address. There's some sensitiveness around the salt value. What that means is like if you do know the salt for someone's address, it's not that hard to figure out what your sweet address is. So that's what we kind of mentioned earlier about where to store the salt. There's two considerations. One is whether you want the user to remember some secret value, even though it's not as sensitive as a private key, but the user do need to remember this value. On the other side, you could have a backend server, and the server knows the salt value, and it can match its users to their address. User doesn't need to remember a salt anymore, but someone needs to. And also a detail to note here is that the prover itself actually also knows the salt. It is used to generate the ZK proof. So it is important to also understand that whomever knows the salt can link your identities in some way. So there's a couple options of running the who runs the prover. We have two options so far. Is that we provided Docker image backend instructions of how to run it within your application. Alternatively, there's an endpoint that you can use as API if you want Misten Labs to run the prover for you, and you just need to make an API call. So we do offer these two kind of options for people to choose from, and understanding their trade-offs of who knows the user information of your application. So that kind of concludes everything I wanted to discuss about zkLogin, how it works, and how to practically integrate an application, and how it's possible for people to not to need to remember a private key or mnemonics in their wallet. In fact, a really powerful idea I'm really excited about for zkLogin is that there's actually no need for a wallet to exist for that exact reason. There is no secure storage of a private key anymore. It is only active for a certain period of session for your particular application. So I have a link here. Feel free to visit this sweetkpay.com if you like. And I'm also going to share my screen about this page just to show you what this looks like. This is the application we built to send a sweet to your friends. If you like to ignore the second part, connect the wallet, this looks very identical to application that has nothing to do with Web3. Let's click sign in with Google. And since I already logged in with joy@mistenlabs.com, I already have an address here generated based on my JWT token. It happened really fast, but there was a redirect in the URL where the JWT token was found, and this application has a few things running in the backend that gets me the address. So I already have a street address here, and I'm able to create a link to send anyone to claim a suite. So I'm going to create a small amount here. and link created. This is my suite address, and I am going to paste in the chat here. Oh, I'm not connected to account. Give me one sec. So I think I'm having trouble to send to the chat, but I'm gonna message Harrison. I pasted a link in the chat with you. If you can share with external, there's 0.1 ETH. SWI. Sorry. In this link, and you should be able to claim your suite using it. I am going to share, going to share my presentation again. So the application, you can play around with it. You can sign in and create links for people to claim your suite and send it around. And as you notice, there's actually nowhere that tells you to log it, to connect your wallet or to remember your private key or anything. Everything happens in the background. So that's a kind of the powerful part of zkLogin, is that you can create this very smooth, familiar OAuth flow for the user, and they can interact with your application without knowing there's a blockchain or this idea of wallet, set up a wallet, back up your private key, etc. So this is just to give you an idea of how to use it, and hopefully you're interested to create an application with zkLogin. And finally, I like to answer some questions from the audience. I have some prepared questions ahead of time, where if someone wants to type in either 1, 2, 3, 4 in the chat, we can go over it, and otherwise I'll pick up some questions. Cool. I think I see a question on the screen here. To repeat, does ephemeral account needs to have fund? That's a good question. So when you need to send money out of the account, you do need to have fund with the account. Just to be clear, actually, take a step back. There is no ephemeral account. A zkLogin account, you have a zkLogin address, and that's permanent. It is always consistent, no matter you've logged in, logged out. If you Google or refreshed your page, whatever, your zkLogin address is always for you. So there's nothing like ephemeral account where this account will disappear or anything. The only thing here is that an ephemeral key might be refreshed, but your zkLogin address still remain the same. So again, if you wanted to send anything out of your zkLogin address, you do have to have money in your address. Next question, how does the zkLogin work across browser and machine? If I'm already logged into a browser, is it cached so the login session is persisted? So the first part, does zkLogin work across browser and machine? That's a good question, because there's a client ID that we talked about earlier. So if you have an application that, say, has a browser one application or a phone application, it may change. It depends on how you define the client ID. If you share one client ID, your zkLogin doesn't change at all. To answer your second question, to answer it differently, where you have an application, let's play videogame.com on your laptop and versus playing it on your phone, your account doesn't change at all. So one address is persistent on chain. So if you send money there and then you send another amount on your phone, it's reflected on your zkLogin address together. If you're already logged in your browser, is it cached? I believe it's not cached across devices. This is a OAuth provider specific question. I believe if you log into your laptop browser with Google on your phone, you still have to log in again. But at the same time, the zkLogin address doesn't change no matter where you log in from. Cool. Cool. Is the proof generation done in the user client? It's a good question. In a current implementation, we use a proving system called Groth 16. It is a proving system that has a really succinct proof. And a trade-off that proving system is that the proving time can be long. So technically speaking, you can generate the proof anywhere you want. It could be on the user client side. It could be in a WASM running your browser or anything on the client side. You are able to run it on your client side if you're concerned about privacy, about not giving your JWT token to anywhere else. It is a trade-off because generating a proof on the client side can take up to minutes, a few minutes, and I think some devices we've seen like 10 minutes proof generation time. And you're right that there is a concern whether whether it's okay for the proving service to see the JWT token. We did share the Docker image to run the proving generation yourself if you like to try that. And another idea, you can run it in like some secure enclave where nobody can see the content. Why is it necessary to identify the user using address that is derived from the sub, ISS, and odd? As I mentioned earlier, you need a way to have a zkLogin address that can be derived consistently, no matter whether you're logged in or not, many times, or you log into a different device. Because we cannot use the ephemeral public key anymore, we cannot derive it using the public key itself. We need to use the persistent field in the JWT token, and we know they're persistent because that's part of the OpenID Connect protocol spec. Is the proof of JWT token valid during the validity period? Does the verification of validity period depends on Oracle data? That's a very good question. Something I didn't mention in the slide is how we get the JWK of the providers on chain. You might be familiar with how to verify JWT token is that you use the public key of Google or any OAuth provider pulled from authenticated endpoint. I believe Google's endpoint is called like search.google.com or something. And they actually rotate their public key every week. And in order to verify the proof itself, we need to get the latest JWK, which is the Google public key from on-chain somewhere consistently in the validators. The way we achieve that is by using the validator set that we already have to secure the Sui network. What they do is by the end of epoch, they will look at, they will pull from this authenticated endpoint of what the latest public key of Google or other providers there are and vote on it. So we're sure that the correct view of the public key is up to date on chain that way. What crypto algorithm is used for salt? A simple answer is you can use anything for the salt. It is a value that you need to remember about how to link, how to generate this value. It's defined as a big integer or anything that that is 32 bytes, and that's enough entropy for that. And the way that we use to generate, we implement the salt server with the example implementation. We use a function called key derivation function. It is based on SHA-256, and we have a master C to save on the server, and then you always derive the salt consistently for the same user as long as the sub ID does not change. So it is a simple way of remembering deriving salt. Did you use Circon plus Node.js for circuit consideration and proof generation? Does the hash use Poseidon? That's correct. We wrote the Groth16 circuit in Circon, and we use Node.js to generate the RNCS, and we run a trusted setup ceremony to commit to the common reference string of for the proving key and the verifying key. And to add on to earlier question about the proving server, we do use Rapid Snark in the server side, which is a lot faster than the Snark.js implementation for proof generation. And yes, we did use Poseidon hash in the circuit to optimize for the constraints. And to give a little bit more information, we have around like 1 million constraints in the circuit, and the proof generation on the server side is roughly around under 3 seconds. Does each JWT service provider configures its own service? The answer is no. We actually configure a universal circuit that works for all the providers. It is to note that we set a certain upper bound on the certain field in the JWT. So for most of the service providers that we've looked at, the length of the certain fields falls under the limit, such that our circuit can be reused for all the providers. So to add on to that, we are able to support more providers in the future without needing to rewrite the circuit or run a new trusted setup. Can multiple ephemeral key be simultaneously used for a given public address? That's a good question. I think there's nothing stopping you from having multiple ones, because a public address is derived from your GWT token, but the private key itself, you pretty much have to generate different proofs for different private keys. I'm not sure if that's like a good user experience. You usually expect to log in once to your application and you should be done for a period of time, and you use that private key and it should be able to transact with on-chain. Yeah, although there's nothing stopping you from doing that. Transaction cost on chain is paid by who? It is still paid by you, whatever fund you have in your zkLogin address. Although you're able to use sponsor transaction, integrate with sponsor transaction to be able to have someone else pays for your gas, and that doesn't change. That doesn't change the fact that you can still use zkLogin, but the other person who signed for your gas transaction can use some other signature scheme as they wish. How long does the open source proving service require to generate a proof? The one we shared on the Sweet Dogs, if you go to the zkLogin page, you can see one of the options called run the proving service in your backend. We actually provide the same Docker image that we use to run our own prover. So I would say if you provision it to the right machine, it should take under 3 seconds to generate the proof. It seems like a different client ID result in different address. Does that mean I have a unique account per dApp? That's a very good question. It is true that because um, we derive the client I we use the client ID to derive the address. We made a intentional decision that there's no portabilities between applications in zkLogin address for now. So you will have a unique account per dApp. Where is the private key stored for the zkLogin account? So the fund can be spent later by the user. Um, yeah, so the private key is stored in your front-end application. It could be in your wallet that integrate with zkLogin, or it can be your front-end application that doesn't have a wallet at all. And the fund can be spent later by the user, yes. So you noticed if you log in with the same zkLogin, if you log in with Google to the same application, you still see your fund exist in that account. Because the change of the private key does not affect your fund at all. It still sits in the same account that is associated with your Google credential. Can private key be exported to be stored in wallet? Yes, it's an ephemeral private key. You can export it anywhere. Although I don't know what value you're gaining out of it because um, if you import it anywhere else, um, it doesn't it doesn't have the money. It doesn't have your fund relating to zkLogin. Although you're welcome to use it, but that's not the point of zkLogin. The point is you don't need to deal with private key ever. You don't even need to know it exists. Is there a required or recommended minimum complexity for the salt value? That's a good question. It doesn't. We don't have particular requirement. It's just something that the user needs to remember. And if it's something, you can think of this as a password. If it's very easy to guess, it's like 1, 2, 3, 4, 5. Yeah, then people can figure out the salt value and figure out what your address is corresponding to your Google ID. So we recommend something like 32 bytes for the salt value entropy.
Whew, that was quite a few questions.
Yeah, there is.
Wow, great job, Joy. Let's wait, there's one more question. Sorry, one more
No
question just
problem.
came on.
Time.
So I'll go back off.
If the client and dApp shuts down, does that mean I lose control of all the accounts and funds? That's a very good question. Because Google is the one that actually manages your client ID, it is a consideration. Is a risk that if Google ever shuts down your client ID. Although we are implementing a multi-sig on top of zkLogin, and we're hoping to have that ready in production the next month. The idea there is that you can set up a multi-sig, like say 1 out of 2, and one of them is a zkLogin and one of them is a private key. So the idea is that you can use the zkLogin most of the time if your client ID is working. If you're really scared of Google shutting you down, you have a fallback of a private key. But the idea is don't keep a lot of money in zkLogin. It is supposed to be convenient and easy. Don't store your net worth in there. Use a actual wallet that doesn't need to rely on any trust in anyone. Is it safe to expose subfield to the public? The way we treat a sub in the JWT token is something sensitive. It should only belong to you. Although at the same time, it is part of your JWT token. For example, Google, they use a globally unique sub ID So it doesn't matter what application you log into, the application should know your sub ID and doesn't change. So if I log into, let's say like Google Grafana.com, and then they will get the sub ID for you. So it's not something secretive, but you shouldn't publish it. But like it's not that hard to find out what your sub ID is. So that's why we use the salt to really hide this value. And another alternative that we thought about is to use the email field, because a lot of the JW token has an email, and we know that email is a unique value to you as well. So we could potentially derive address that way, but we choose to use the subfield because it's a little bit opaque and harder to figure out compared to email.
Okay. Oof. It's 5 minutes to the end, but I think that was already plenty of questions. So if you guys appreciated Joy taking the time going through this workshop and answering all the questions that you guys asked, please drop a thank you to Joy in the comments. And of course, if you want to learn more, we have these two links. We'll share them in the comments or in the description after it's been uploaded to YouTube. And yeah, stay tuned for more events. I've shared the events to links to events that are. I shared activities that are coming up. That's SWE related for the next few months, so you can check them out on the link that I shared earlier. And SWE is always here to help you guys understand more about SWE Move, and let's try to onboard the next billion users on SWE.
Thank you, everyone.
Thank you, Joy. Thank you so much. Rest well, and we'll see you guys next time.
Bye.